So I asked you to do number 3 or continue working on number 3. I'm gonna go through and highlight or underline important things really fast, which you should have also done. And then we had to first write an equation to represent the total cost to rent and drive the car for one day at the Blue Car Rental. Anyone come up with an equation for that one that wants to share? Jasmine got
27.60
And then after you find your equation, you could have used different variables, that's fine. You need to somewhere list what x and y represent. So Jasmine, what did your x and y represent? What's nice about this is because we're using the same variables for both of these equations, we don't have to do this part again. Then what would the equation for B, the red car rental, be? If it's going to look similar to A. What do we think? Sure.
Like C as in the total cost, so I guess Y.
We're just doing B right now. Oh, but okay. I'm going to use the same variables up here, but that's fine.
Equals 0.14 plus 40.3.
So even though your order is different, it's the same equation. So you put your y equals or c equals first, which is fine. That doesn't matter. You switch these, again, that doesn't matter. As long as you have everything, you're fine. For C, we had to calculate the total cost of both of these using 280 miles. Where would that go? Regina?
It would replace X.
It would go in for X, yes. So let's we know it went in for X because it's talking about miles. We have to go back and look at our definition of what X is. So if you made X your end instead of like we did, just make sure it matches. So you can put this all in at the same time into your calculator. What were our totals for the blue and for the red? Anyone find that?
$78 for the blue.
Okay. Notice that Regina put dollars on that because whatever we're looking for, we have to be specific. We have to label it. And in this case, we're looking for total cost, so dollars. Do we have any questions so far? Okay. D is just asking which would be better. So of these two, which would be better? Otis?
Blue, because you spend $1.60 less.
Let's do it in the same color. So Blue Car Rental, because it's cheaper by $1.60, that may not count for a whole lot, but in the long run, you save $1.60. There you go. Right? Now, the number of miles has changed. So we're still doing both equations and we're seeing which one has a lower cost. If you already solved this, then you know the answer. But if you didn't solve this, which one do you think would have a lower cost based on what we already did? If we were just guessing. Which one do you think, Jasmine?
The red one, because even though it has like a higher base cost, the miles is the price per mile is cheaper.
Okay. So let's see. Let's see if I can copy this. Maybe not. Together now. The 400 would still go in for X because we're still looking at miles. We're still trying to figure out the total cost. What were those two total costs? Simon?
I had 99.60.
For which one?
Blue.
99.6. And that's dollars. And then for the red? 96.4. So now it has switched because there's been more mileage, even though it has a more expensive base price, like you said. This was the cheaper one, the red one. Questions so far? Now F and G switch. Now we're looking for the number of miles driven if these are the total costs. So we, based on what we have so far, we know it has to be probably less than 280 and 400 for both of these. Or sorry, less than 280 for the first one, less than 400 for the second one. So now we're given the y and we have to find x. Let's see, let's make it smaller. Okay, so now we have to solve this for x. How would we do that? Amen.
Plus 27.6. No, subtraction.
Subtract it. Because this is already positive, so we have to do the opposite. Subtract that. Tell me what that is. 43.6. And then our last step?
You divide.
Divide. So what did our x equal? 242.2. Now, with all of our word problems that we may or may not get decimals for, we have to think about this. Can number of miles be a decimal? Yes. You have to count up to get to 1 mile, so there can be decimals. So we can leave that as a decimal. And then we would do the same thing for G. But with its own equation. Just like in F, our first step was to subtract, so we're going to do that same thing. What did we get for the number of miles in G? Otis?
307.14.
307.14. Okay. Was that just 14 or was that other numbers?
I think it was just 14. I don't remember.
Let's do this. That's fine. So here, we just want to round if this is 5 or higher, or depending on the problem, we may need to round anyway, but this one is fine. So that would be our final answer. So normally with these problems, you'll have more like what we did last class, where you're given something, you have to find just one thing. This was just so you can practice multiple things. Do we have any questions on anything from 3? Okay. Lacey, Danielle, go ahead and go back to your seats. And then we are going to do some more word problems before we move on, so that we're comfortable with everything. And we're going to actually go back to number 1. So you'll see a variation of these problems. A lot of them are length and width problems, and then there are specific ways on how we do this. So at first it'll be a little confusing until we practice. So here, important things. The length of a rectangle is 3 inches more than the width. The perimeter is 30 inches. Find the dimensions. What's important there? Otis?
Perimeter means we're adding.
Okay. So I'm going to write this, because instead of doing all 4 of the sides of the rectangle, we can just use that equation. So that is important. What else? Were you raising your hand, Otis? So that ties directly to the length. And then anything else? Any other numbers you see? Otis?
30 inches, which is the final. That's what we're.
Yes, that'll be what it equals at the end. Now, how you think this is probably going to be set up is probably not how it's going to be set up. What is going to happen is we're going to set up this equation first for length, and then use our perimeter to solve at the end. So let's talk about just the length. In these problems, you don't have to define your variables because it's given length and width, you can assume. Because it says the word is, that's like your equals. How would I write 3 inches more than the width? Otis?
3 plus W.
So this is just our equation for length. We have our equation for the perimeter that we know is 30, so I'm going to start that. If we know what our length is, we could put this in for L in parentheses, and then put the rest of the equation. Notice that the L went away because of what L equaled, and that's going to happen. So you start off by writing one equation, you put that into the other, And then we can solve this. What would be our first step?
Distributing.
We have 30 equals 6 plus 2w plus 2w. From there,
It's 30 equals 6 plus 4.
combine our like terms. And then we can solve it like a normal problem. Subtract 6 on both sides. Do this over here. I'm running out of space. And then divide both sides by 4.
We need 8 to be equals
6. And then, because this was inches, we want to be specific, so 6 inches. However, that's only part of our answer because it asks us to find the dimension, so we need both the length and the width.
8. Our length is 9.
And how did you find that?
By adding 3 to our W or 6.
So you would write your length and your width and box those in at the end, and those would be your dimensions. We'll do another problem like this in a second, but do we have questions on this? Once you are finished writing, go ahead to your next page. We're going to do one more like the one we just did, and then we're going to, I'll have you choose some of the other ones. So let's start with number 5. Sure, and then we'll go back. So for this, it's like the length and width problems, but you have highest score and lowest score instead. So the highest score on the algebra test was 42 points more than the lowest. When added together, the lowest and highest score was 154. And then we have to find both the highest and the lowest score. Doesn't really matter what variables you use. If you want to use H and L, you can use S, but not for both. If you use something other than H and L, you may have to tell me what those mean. Like if you use X and Y, I need to know which one is which. So let's talk about H first. The highest score on the algebra test was 42 points more than the lowest. How would I write that as an equation? Think about what we just did for the length. It'll be similar. Otis.
H equals 42 plus L.
Then we know it tells us they are adding the highest and lowest scores together to get 154. So if you wanted to, off to the side, write H plus L equals 154, just so you know what we are about to do, you could do that. It's not necessary. But then we're going to take this equation we found for H and put it in place of the H in this. So it'll look like this. 42 plus L. You can put parentheses, but you don't need them. Plus the L that was already in this equation equals 154. So then the process is the same. Combine your like terms. to solve. Subtract 42 on both sides. Someone subtract that, tell me what you get. 132. I don't think it's 32.
No.
It's 112.
Yeah.
112.
And then divide by 2 and tell me what you get. Go ahead.
How would equals 56?
56. Now, because this is just talking about score, we don't really need a label. If you want to put score, you can, but it's not necessary. So now we have to go back and figure out what H is. So we can put L into this equation for H. Someone do that. Tell me what you get for H. 98. Then our last step is just to make sure that we didn't miss anything. If we add 98 and 56, do we get 154? Yep. So if we did that and it didn't work, somewhere we made a mistake. What questions do we have on this problem, the process, anything? Numbers 1 through 4 are similar, but they're talking about higher number, lower number. Look at those. We'll pick one from one of those, so you can show me on your hand which one you would want to do from those 4. Make sure you're looking at numbers 1 through 4. Tell me which one you would like to do on your hand. We'll go with majority. We're going to do 4. 3 is going to be similar, but a little easier because you're adding and not with all the subtracting. So here we have 2 numbers. We just need 2 different variables. I'm going to say this is going to be S, and I'll color code that. And then this will be L. So larger and smaller numbers. The larger of 2 numbers is twice the smaller number. How would we write that into an equation? Emmett?
L equals 2 times F.
This is the S, not a 5. If 12 is subtracted from the larger number, the result is 7 more than the smaller number. So there's 2 things going on there. If 12 is subtracted from the larger number, so we know this is our equation for L. We're subtracting 12 from it. So we can say 2S minus 12 and then for that second part, the result, that's going to be your equals, is 7 more than the smaller number. How would I write that part? Otis.
7 plus 5.
And I forgot that this was similar to what we're going to talk about today, so we may actually come back and solve this. Let me see if there were any I'll set this one up for you, that way you can solve it. So the larger of two numbers is 1 more than 4 times the smaller number, 1 plus 4s. The sum of the numbers is 106. So this is more like 5 and the other one we did. Because we're adding the larger and the smaller numbers together, and we know that the equation for the larger number is the 1 plus 4s. So you would combine your like terms and start solving for s. Again, I'm not solving that one, but we'll come back to it. And we're not coming back to 3. If you have questions on that later, you can talk about that. We are coming back to 4 though. Look over 6 through 8. There are more words, but they will be set up similarly to the perimeter, the length and width problems, or the problems we just did. Look over those 3, find one you want to do, put it on your hand. Yeah, I was going to say you may put it on your hands because it's 6, 7, and 8, sorry. Unless you're doing sign language, which 6, 7, 8, I think that's what it is. So 8, 7. And that's 8. Okay. 6. We need a tiebreaker. Otis, what number did you have?
9.
So just on 6 through 8.
Oh, I have 8.
Whoever's ringer that is, go turn it off. I was like, has to be one of ours. Is that an alarm? Anyone else have one they want to do specifically out of 6, 7, or 8? We need a tiebreaker.
I probably should look at these before.
We're going to start setting this up for 8, but if it ends up being like the other one, we may not do that one. 10 less red Skittles than orange Skittles. So I'm going to call this R. And then, maybe not R, maybe G. So I can call it R, okay. So it would be G equals what?
R equals 10 or negative 10 plus G.
So these type of word problems are a little confusing, especially when they say the than. Because this is saying if we knew how many orange Skittles there were, there would be 10 less red Skittles.
Okay.
So we kind of have to like read it backwards.
So G equals R plus 10.
I feel like it would still be minus.
Because you're adding the Skittles back, right? So then this would be R plus 10.
Let's see, because now I'm like, I had it backwards, is what it was. That's how it would be. Let's come back to this one. See, I forgot this one is a harder one. We'll come back to this section in general. Let's get to rectangles, perimeter, length, and width. So of 9 through, 11, find one you want to go over. So Emmett, you wanted to do 11.
No, I was wondering how you would do that.
Oh, or what's 11 in sign language? 1, yeah. Or like that, yeah, sure.
Yeah, it's like thinking. Oh,
Do that. Yeah, there you go.
I don't have coordination. Oh! I could like.
So we have 10, 9. I think we have 2 for 9 and 2 for 10. We need a tiebreaker. Say 9 and 10 are similar. 11 is different because it's subtracting, so either or. And you pick one. You don't have to pick 10 if you don't want to pick 10. Alright, so 10. And then 9 is similar, so it'll be set up the same. Length of a rectangle is 5 inches more than 4 times its width. It's a lot. How would we set up that equation? Five inches more than 4 times its width. What operations are we doing there? Addition and what was the other one? Multiplication. We're adding and then multiplying. So how would we write it?
5 plus 2 times W.
Say that last word again.
2 times W.
Not 2.
Oh, 4.
4. There you go.
That's why.
You're thinking ahead to our perimeter equation. So then, we know our perimeter equation, 2 times length plus 2 times width. We know the perimeter equals 90, so we're going to set that up. 90 equals 2 times our entire length equation. And then plus our 2w at the end. Do we feel like we can confidently solve this? It was just the setting up part. Okay. So I'll let you solve that. I'll give you a couple minutes to do that, and then we'll come back and talk about that, and then switch gears. Good.
The width is 8 inches and length is 37.
So a lot of you were on the right track with the width, and then you got stuck with the length. So make sure after you get the width, you take this and you put it back into our length equation to solve and find that length. Okay. I just want to start this. We probably won't get that far, but that's okay. The next set of notes, and then we'll come back to these. So far, we've been talking about just solving equations that were all on one side. We brought everything to the other and then solved. But now we're going to have equations where variables are on both sides. And we have to figure out what do we do with those. So this is a good mnemonic, I think that's what it's called, to help you remember. It's kind of the same instructions for solving equations in general. It's don't call me after midnight. And that stands for distribute. Combine like terms. Move the constant or variable. And you do that by adding or subtracting. And then at the end, you multiply or divide to get the variable by itself. So same kind of steps we would do normally in a regular equation, which is something to help you remember it. Why? Don't call me after midnight, distribute, combine like terms, move the constant or variable, add or subtract, multiply, divide. So this problem has like all of this. Not all of your problems will have all of this, and that's okay. So with this problem, we're going to start off with the distribute. We're going to distribute on both sides at the same time. So that would end up being 8x plus 4 minus 2x equals 8 plus 4x plus 20. We bring down everything. There we go. Then when you combine like terms, you're only doing it on the same side. We're not moving things to other sides yet. So on this left side, what like terms do we have? 8x and negative 2x. On the other side, what like terms do we have? 8 and 20. So notice that the other terms that are similar, I'm disregarding those for now. Regina.
Do you want us to like circle it or not?
You don't have to. Just if you go back and watch this video, that it's there so we know what we did. So this would be 6x plus 4 equals 28 plus 4x. Then we have choices. You can choose any of these terms to move to the other side. Does not matter which one. So of the 4 terms we have 6x, 4, 28, 4x, which one do we want to move first? Let's see. 4x, okay. Everyone does not have to choose the same one. Everyone could choose a different one. The end goal is still get all the variables on one side, all the constants on the other. So if we move 4x over, it was positive, we would have to subtract. This is our moving. You really end up moving twice. You move a constant and then you move a variable. Later, I'll show you how to do that at the same time. Because we moved something to the left, we now have to move something back to the right. The opposite of whatever we moved before. We moved a variable this time, so we have to move this constant now to the other side. And then to get x by itself, we would do what? Divide. By 2. So that's our multiply or divide, but in this case we divided. I'm just going to put the answer at the bottom. So if we wanted to double check, remember you have different tools. You can put it into your calculator, but you'd have to do both sides. You can put them in separately, together. You could use Desmos and make sure that's your answer. Somewhere, if you're practicing at home, make sure that you're double checking your answer. Questions on this before we move on? We'll do 2 of these. I'll let you do 2, and then we might have time to do 1 practice problem. Okay, so let's start with this first one. This is like what we did the other day, where we're listing out the steps. What did they do to get to the next step? It's already solved for us. So in this first one, it is given. What did they do from step 1 to step 2? Hyman.
They did 2k minus.
They subtracted
And
the
then
2k.
Yeah, and then they did 10k minus 2k.
Okay, so subtraction property of equality. To get the 8k and get rid of the 2k on the other side. And then what? Lacey? Addition. What did they add? 4 to both sides. And then our last step. Division, yes. Divided everything by 8. Questions on that one? We're going to do the very last one, and then I'm going to let you do 5 and 6. So now this is similar to what we just did. Don't call me after midnight. We have things that are distributing, combining the terms. We just need to keep all of those in mind. Yes, Regina. Yes, we distributed first. From step 2 to step 3, what did we do? I'm sorry, no, what I said was right. Step 2 to step 3. Think about your don't call me after midnight. What's missing from step 2 to step 3?
You distributed.
We already distributed. Lacey,
Yeah.
what were you going to say? We combine our like terms. The 14 and the negative 16 to get the negative 2. And then the 5x and the negative 3x to get the 2x. So we just combine our like terms. Then from step 3 to step 4, be careful with this one. Jaden?
You have negative 2 to the 4.
Do you add it? Yeah, you subtracted it. That's why I said be careful with this one because it's already positive, it's turning more negative. But we did subtract. In normal problems, yes, you could have done it either way, but in this one, we couldn't have moved this over because there's no x's on this term, on this side. So
Oh, sorry.
this is, yeah, because it's already solved. This is only one way, Jaden. Yes. So from step 4 to step 5, you add 2 to both sides, yes. And then our last step, divide. Do we have any questions on that process? How we got any of those? Try 5 and 6. I'll give you a minute or two to do those, and then we'll come back and we'll talk about them. Oh, I meant to give you one of these. So if you didn't know the last one for 5, that's okay. So for 5, you should have had subtraction, division, and then this last one was actually symmetric, where they just switched the order because the order doesn't matter. So if you didn't get that one, that's okay. I meant to give you that one, I forgot. Questions on 5? Six was distributive property or distribution property, addition, addition again, and then division. Questions on that one? Pick. We'll do one problem that you see that you're not sure how to start, looks complicated, anything like that, you can tell me. 4. And then any other ones we will do next class. 3. Any others from this page? 6. Okay, you can just tell me. 2, and 6, and 5. Okay. 7, I'm not going to do today or next class because it's similar to the other fraction problems we have on here. Any others? I just want to write all these down so I have them for next time. Okay, so we're going to do 4 today and then the others next class. Right, so on number 4, anytime we have a fraction that equals a fraction, we have to do something first. Does anyone know what that something is? Not divide. Multiply what?
The denominator to the other denominator.
You're close. Not that either. We're actually going to cross multiply, where we're going to multiply the numerator to the denominator of the opposite one, and vice versa. So if you want to rewrite this, get in the habit of rewriting it first, and then go from there, that's fine. After you get used to it and want to just jump into the next step, that's also fine. So we're going to take this 3 and multiply it to everything here, so I'm going to write it in parentheses. Then we still need our equals. And then I'm going to multiply the 9 to everything here. So then, what would be our next step? Distribute. Using our don't call me after midnight, distribute first. So we have 27x minus 9 equals 45x plus 45. Do we have like terms we can combine on the same side? No. So if we don't have that, we cannot combine terms that are not on the same side. And if they are on the same side, we're just doing whatever it says. If they're not, then we move. So let's pick one thing we want to move first. Of the 4 terms, what do you want to move first? Doesn't matter. 27x, negative 9, 45x, 45, 27, okay? If you wanted to move anything else first, that's fine. 45 minus 27 would give us what? Negative what? I think it would be positive, but yes. And then because we moved our x term to the right, we have to move our constant back to the left. We'll do this off to the side. So we have negative equals 18x. And then divide everything by 18. So what would x equal? Negative 3. There we go. If you wanted to write it the other way, x equals negative 3, that's fine. The order does not matter. And then if I want to check this, I'm going to do this in Desmos really fast. Someone tell me what that equation was again. 9x. Remember, if you type in your entire equation, it'll give you an answer. Negative 3 was our answer, so that's right. Okay, so on this page, there are problems. I would say try some of these. At the very least, see if you can do 7 by next class. I'll be checking for 7. It'll be very similar to what we just did. Cross multiply and continue. So 7 will be the problem I check and we go over. And then we'll also go back to that word problem I said we'll go back to, which was number 4 for certain, and then 8.